So, second unit, biochemical and non-electrical parameter measurement. Okay, so there we studied about the origin of biopotential as well as ECG, EG measurement. Okay, here we are going to see biochemical and non-electrical parameter measurement. So, under that, you will be having pH, pO2, pCO2 measurement, calorimeter, blood flow meter, cardiac output, respiratory system, blood pressure, temperature and pulse measurement, and then blood cell counter. So these are the topics will be covered in the second unit. So first we are going to see about the measurement of pH, pO2 and pCO2. What is pH measurement? What is pH measurement? Any one of you? Any idea? I think you will be learned in chemistry. pH. What is pH? pH. What it stands for? Potential of hydrogen. Okay. Potential of hydrogen. That is, it will measure the concentration of hydrogen ion. Okay. It is proton in the substance will be measured. Okay. So presence of that is potential of hydrogen ion concentration will be measured in the substance. Okay, simply we can call it as proton. So pH measurement specify the degree of relative acidity or alkalinity of a solution at a given temperature. So pH measurement helps to find out the degree of relative acidity, whether the given solution is acidity or alkalinity content. Okay, that will be measured using the pH measurement. Okay, so pH is defined as hydrogen ion concentration in fluid. So how we can calculate means pH equal to, the formula given for pH is minus log of H plus. H plus is nothing but hydrogen ion. Okay, positive hydrogen ion. So in the pure water or neutral solution, you'll be having the hydrogen concentration value will be 1 into 10 power minus 7. Okay, so that will be replaced here. Okay, 1 into 10 power minus 7 is replaced in the formula. Okay, so that you will be getting pH equal to minus log of 1 into 10 power minus 7. So apply the logarithm value for both the values inside the bracket, so that you'll be getting log 1 into log 10 power minus 7. So log 1 value is 0. So into will become plus in logarithm. Okay, I think you all know maths. Then here minus 7 will come front side. Okay, power will come front side. uh, Log 10 will give the value of 1, I think so. In that will be altogether will be 7. Okay, minus 7, because we are going to bring the power value to the front of log upper minus 7 you'll be getting. So totally minus into minus will become 7. So plus 7 will be the answer for pH. Okay, so pH value for the water, pure water is 7. So as stated by Goldman equation, the electrolyte potential of the membrane is proportional to the logarithm of ion concentration and electrolyte temperature. So Goldman equation statement gives you that the electrolyte potential, electrolyte is nothing but the substance which will conduct the electricity will be called as a electrolyte. Okay, so the electrolyte potential, potential means voltage, anything else strength. Okay, so potential of the membrane will be directly proportional to the logarithm of ion concentration. What ion concentration here? Hydrogen ion concentration and electrolyte temperature. Okay, so the chemical balance in a human body is determined due to the pH value of blood and other fluids. Okay, we can say the chemical balance in your human body can be measured by finding the pH value in blood or any other fluids in the body. Okay, so that pH value of blood will give the chemical balance of human body. So how we are going to measure? pH measurement can be taken from pH meter. Okay, so by using pH meter you can measure the pH value, okay, of any liquids or solution. Okay, so here pH meter measures acid and base in a fluid. So whether it is acidity or alkalinity. Okay, so in the first slide itself I said the pH measurement is nothing but it will specify whether the given solution is acidity or alkalinity. Other than acid, alkalinity, other name for alkalinity is base. We can call the alkalinity as base. Okay, acid or base. So pH meter measures acid and base in a fluid. So when the solution is neutral, okay, its pH value will be 7. When the solution is less than 7, less than 7 means pH value is less than 7, then your solution will be called as acidic. Okay, if it is more than 7, pH value is more than 7 means it will indicate that your solution is basic. Okay, your solution has base. So pH meter will helps to find out whether the solution is base or acidic or neutral. Okay, if your pH meter indicates the value of 7, then your solution is said to be neutral. If it is less than 7, your pH value is less than 7, then your solution will be said to be acidic nature. And then if it is greater than 7, it will be in basic nature. Okay, so these are the conditions. So here a pH meter consists of thin glass membrane that allows only hydrogen ions to pass through it. So pH meter, this is pH meter. Okay, so in the pH meter you will be having thin membrane, so that will allow only the hydrogen ion to pass. So the remaining ions will be blocked. Okay, so it will permit only the hydrogen ions to enter into it. So this is pH meter. This is pH meter with a combination electrode. Okay. So here you will be having bulb with the buffered solution. Okay. This is said to be, this is bulb, glass bulb. Okay. This round shape is bulged shape is glass bulb with the buffered solution. Here this central point, thin line like having no, that will be called as active electrode. Active electrode is silver and silver chloride. Your active electrode is made up of silver and silver chloride. The outer, the entire setup is covered by a pH glass. Okay, so you can enter the solution which you want to measure through this entrance. Here this is nothing but you'll be having the same pH meter with the help of electrode inserted into it. Okay, that is represented in this diagram, without electrode, with electrode. Okay, this is the full pH measurement setup. So you will be taking the solution in the container, okay, which you want to measure. That will be taken in a container. You will be having the two electrodes, okay. One is active electrode and another one will be a reference electrode, okay. So active electrode only will be having that bulb at the edge, okay. In that you will be using silver chloride substance, as well as you will be having the glass membrane here, which will be permitting only the hydrogen ion to enter into it. And then buffer solution is present here. Then glass is sealed in this electrode, okay. This will be called as the entire part of this will be altogether called as measuring electrode or active electrode or measuring electrode, okay. So this is a reference electrode right side. One is reference electrode. So reference electrode will be having liquids junction at the edge, and then above that you will be having silver chloride, okay. This is silver chloride, ஒரு டங்ஸ்டன் மாதிரி இருக்கு இல்லையா, filament மாதிரி, that will be called as silver chloride. And then that is filled with the potassium chloride liquid or gel, okay. So the entire uh, this needle will be called as a reference electrode. So in between the reference electrode and acting electrode you will be having temperature sensor, okay. So this reference electrode, measuring electrode, will be connected through the voltmeter, high impedance voltmeter, okay. So a container is filled with a solution which want to be measured the pH value, okay. So explanation of this diagram is given here. A glass bulb is present at the bottom of the pH meter that contains highly acidic buffer solution, okay. So your active electrode contains glass bulb. At the bottom of the glass bulb you will be having the buffer solution. So glass tube is using silver. AgA is nothing but silver chloride electrode and a calomel reference electrode, okay. So chloride electrode is your active electrode. Calomel reference electrode. Reference electrode is made up of calomel. So it is placed inside the solution for which pH is to be measured, okay. So you are going to place the two electrodes in a container which is filled with a measuring solution, okay. pH value measuring solution. Then across two electrode potential is measured. So we are going to measure the potential value for the given substance in the container in between the two electrodes using voltmeter, okay. So electrochemical measurement obtained between two electrode is known as half cell potential. So the electrochemical measurement, that is voltage we are obtaining at the voltmeter which is connected between the two electrode is said to be half cell potential, okay. So why it's named as half cell means, in this setup the glass electrode inside the glass tube will act as a one of the half cell, okay, and then reference electrode will act as the another half cell, okay. That's why the name half cell potential, okay. So each electrode will be considered as a half cell. So both electrode, so one half cell reference electrode, another half cell is acting electrode, okay. That's why the name half cell potential. And then for ECPH measurement, electrode combination is used. So based on the electrode combination only, you are going to measure the pH value. You can select as your need the type of electrodes to measurement. Okay. So glass electrodes is preferred for uh, finding the pH value for up to 7. Okay, up to 7 means acid. Okay, if your solution is acid means, then you can use the glass electrode to find out the pH value. Okay, so special type of pH electrode are used when glass electrode produces error. If you feel that your measurement is having error, then you can use the special type of pH electrode which is available. Okay. The next, it measures pH at all temperature. At all temperature, you can measure the pH value. So pH meter has glass, that is the glass electrode is active electrode, and silver and silver chloride electrode as a terminal. Okay. So potassium chloride is used as the electrolyte solution in the pH meter, and an active terminal is sealed using glass that has hydrated glass layer. So your active electrode going to be fully sealed with the glass to which will be having the hydrated glass layer. Hydrated glass layer means it will permit only the hydrogen ion concentration alone. And then both these electrodes are enclosed inside a single glass tube. So these two electrodes are enclosed in a single glass tube itself. Okay. Now we are going to see about the pO2 measurement. So far we seen about the pH measurement, that is potential of hydrogen ion presentation in a solution. How we are going to find out this pH value in a solution. Okay. Now we are going to see the pO2 measurement, potential of oxygen. Okay, before that hydrogen, now oxygen. pO2 measurement. This is the setup of pO2 measurement. Okay, so in the container you will be having the measuring solution. So inside that container you are going to have another one container with the electrolyte solution. So electrolyte solution is nothing but substance which will be conducting the electricity. Okay, so in that container the bottom layer will be a membrane which will be diffusing oxygen. Okay, to the solution. So in between these two liquids or solution, this layer will be acting as a sieve. That is, it will be like a interface between these two solution for oxygen. Okay. So in the inside container, you'll be placing the two electrode. One will be the acting electrode, that is made of glass. Then another one will be aluminium, sorry, silver chloride electrode, which will be acting as a reference electrode. Okay. So these two electrode will be connected with battery. Okay, or supply, and also you'll be having one ammeter. Okay. So in the pO2 measurement, the platinum wire will be acting as the active electrode which is covered by the glass for insulation. This is acting electrode. Okay, which will be having platinum wire which is enclosed by glass for insulation. So they are combined with the glass for insulation, and only the tip is exposed to the solution. See here, the tip of the platinum wire will be dipped in the solution of electrolyte. So here oxygen is diffused into the electrolyte solution. Okay, so oxygen will be diffused through the membrane, bottom membrane of this container. Then silver chloride act as reference electrode. So between platinum wire and reference electrode, you will be connecting the zero point 0.7 voltage power supply. Okay. So active electrode is connected to negative terminal. So see, this is active electrode. This is connected to negative terminal, but your reference electrode is connected to positive terminal. Okay. So at the platinum electrode, oxygen reduction occur due to the negative terminal connection. So since your platinum wire, that is platinum electrode or active electrode, is connected to negative terminal, it going to have the oxygen reduction reaction. Okay. So the amount of oxidation reduction current is proportional to the partial pressure of oxygen present in the electrolyte. So amount of oxidation reduction current will be measured in the ammeter which is present in between the two electrodes, that is active electrode and reference electrode. So the measured current value in the ammeter will be proportional to the partial pressure of oxygen present in the electrolyte solution. Okay, so electrolyte solution, oxygen content will be measured in the current which is measured across the two electrodes. Okay, so between, so this partial pressure of oxygen is measured through microammeter. So micrometer is nothing but microamps, in range of microamps. Okay, so next, first we seen pH measurement and then pO2. Next, pCO2 measurement. Okay, wait a minute.